What we're going to do here is to solve this Unit 4 paper question on rates of reaction, which I found to be very tricky. We're going to use a method that you can use for any rate equation, for solving any rate equation. So if we write a general rate equation for this reaction, we can see that the rate is equal to the rate constant multiplied by the concentration of reactant D, and we'll raise that to the power x. That's what we're trying to find, the order with respect to the concentration of D, multiplied by reactant A, concentration of E, and we still don't know the order of reaction with respect to E, so we'll give that a value y. Now, in order to get rid of this pesky constant, we can use simultaneous equations, because since that doesn't change, we can say, for example, let's choose two experiments. Let's choose experiments 2 and 3, because conveniently in experiments 2 and 3, the concentration of D has been kept the same and the concentration of E has been varied. So immediately we know we should be able to solve the order with respect to the concentration of E, the effect of changing the concentration of E, what effect does that have on the rate. So what we do is we choose experiments 2 and 3. Since the rate is larger in experiment 3, we're going to put that one on the top. So we'll say that the rate in experiment 3 divided by the rate in experiment 2 is equal to the rate constant divided by the rate constant, that will cancel out, multiplied by the concentration of D in experiment 2 divided by the concentration of D in experiment 3. Concentration of D in experiment 3 divided by the concentration of D in experiment 2, so power x, multiplied by the concentration of E in experiment 3 divided by the concentration of E in experiment 2, so power y. Now immediately, because the concentration of D in experiment 3 and experiment 2 is the same, that cancels out conveniently as well. So now what we can do is put the values in. So the rate in experiment 3, the initial rate in experiment 3 is 1.57 times 10 to the minus 1, 1.57 times 10 to the minus 1, divided by the rate in experiment 2, which is 3.92 times 10 to the minus 2. The concentration of E in experiment 3 is 1.75, divided by the concentration of E in experiment 3 is 8.73 times 10 to the minus 1, raised to the power y, because that's the order that we're trying to find. Simplifying this, go to your calculator, that comes out to approximately 4, and that comes out to 2 to the power y. So therefore y must be 2, 2 squared is 4, so therefore it's second order with respect to the concentration of E. What we can now do, now we've just discovered that it's second order with respect to the concentration of E. But how are we going to find the order with respect to the concentration of D when there are no two experiments where the concentration of E has been kept constant? We're going to use our simultaneous equations again. And this time, let's choose any two experiments. Let's choose experiment 1 and 3, where we varied the concentration of D. It doesn't matter that we've varied the concentration of E, because we already know the order with respect to the concentration of E. So let's choose experiments 1 and 3 to compare. So again, using our simultaneous equation, we know that the rate, so let's choose the faster rate to go on the top just to make our lives simpler. So that's the rate in experiment 3 divided by the rate in experiment 1 is equal to the concentration of D. Remember, the velocity constant, rate constant cancels out. So the concentration of D in experiment 3 divided by the concentration of D in experiment 1. Don't know the order with respect to D yet, so we'll give that a value of X. Multiplied by the concentration of E in experiment 3, and we know that already that's second order with respect to the concentration of E, divided by the concentration of E squared in experiment 1. Let's now substitute in our values, looking at the data we've been given. So the rate in experiment 3 is 1.57 times 10 to the minus 1. The rate in experiment 1 is 1.16 times 10 to the minus 2, and that is equal to the concentration of D in experiment 3, which is 1.88 times 10 to the minus 2, divided by the concentration of D in experiment 1, which is 1.25 times 10 to the minus 2. We don't know the order with respect to D, but since the order is the same, we can simplify that, raising it to the power of X. We also know the concentration of E in experiment 3 is 1.75 divided by the concentration of E in experiment 1, which is 5.81 times 10 to the minus 1. And we know that that's second order, so we can square it. Go to your calculators now. That simplifies to 13.53, and that simplifies to 1.504 to the power of X, because we still don't know the concentration, and this simplified to 9.072. Take this over to the other side. That comes to 13.53 over 9.072, which equals 1.504 to the power X. That comes to 1.49. That's approximately 1.5, 1.49, 1.5 to the X, and therefore X equals 1, and it's first order with respect to the concentration of component E.